Okay, today you're going to be working on a free fall problem set. You're going to use the equations that were on the last slide of the last set of notes you took over free fall. Okay, for the purpose of this worksheet, you're mainly going to be using these formulas. This formula and this formula are the same thing. The difference is this one, the object already has an acceleration. It's already falling. And then you're given an initial velocity and it continues to fall. On this side, these objects start from rest. So let's say you have your cliff, you have your person up here, and they are dropping something off a cliff. The initial velocity equals 0. So if you took 0 for the initial velocity, you zero out all these initial velocities, you're going to get this equation. So this equation and this equation, this one and this one, this one and this one, you get the idea, are all the same equations except the initial velocity has been zeroed out and taken out of these to create this equation. The most complicated part of today's assignment is rearranging the equation to suit what you need. Okay. This first one. An object falls from a high building, ignoring air resistance. What will its velocity be after 6 seconds of falling? Okay, let's see what it's asking for. It's asking for what will the velocity be? So it's asking for the final velocity. It gives you 6 seconds, so it gives you time. You know, you know what G is. G is a constant. It will never change. This is the acceleration due to gravity. So an object will keep going faster and faster and faster, accelerating towards the earth, okay, until something else acts on it, like the ground. But G is always 9.81 meters per second squared. So you know G. So let's look at our equations. It's looking for final velocity. Okay, you could use this one or this one. In this one, you need to know how far it fell. We don't know that. We don't know how tall the building is. But this one, it only asks for G and time. So G multiplied by the change of time. So G final, the final velocity is equal to G times how long it took. So we know G, 9.81 meters per second squared. And you know T, and it's 6 seconds. So 6 times 9.81 meters per second squared will give you the answer. Okay, I'm going to skip down to this one right here because it takes a little bit of manipulation, and you probably want, once you get the equation manipulated, you're going to want to write it on your equation sheet. During the tornado, the Peachtree Plaza Westin Hotel in downtown Atlanta suffered damage. Suppose a piece of glass dropped near the top of the hotel and fell 215 meters. So here's the hotel. Near the top, a piece of glass is falling. You know it fell, so your delta Y is going to be the 215 meters. So you know how far it fell. Ignoring air resistance, how long would it take, so it's asking for time, to take the piece of glass to hit the ground? You know delta Y, you're asking for time, And of course, you know G. So which one of these equations? Here we have this equation. We know delta Y, we know G, and we're looking for T. To rearrange this equation, delta Y equals 1/2 times G times time squared. So we're just going to rearrange this equation. So you're going to get everything but time over to this side. So delta Y, you're dividing by 2 on this side, so you're going to you're going to multiply each side by 2 to get this part over here. So 1/2 times the 2 cancels each other out. And so you have 2 on this side. Again, all I did was multiply both sides by 2. This cancels out, and you have 2y on this side. So now we have G times delta T squared. We're going to get the G on the other side, so we're going to divide both sides by G. And that leaves us 2y divided by G equals the change of time squared. Okay, this is squared. We're going to want to get rid of the squared. We just want time. So you're going to take the square root of both sides, and that leaves you, so this cancels that, and you have the square root. So you're going to have the change of time, which we are looking for, equals the square root of 2 times how far it falls, the vertical difference, divided by G. Okay? You will use this equation several times in today's assignment. So I would add it to your list. So your delta time is going to equal the square root of 2 times the distance it falls divided by G. That will give you the square root of 2 times 215 meters divided by 9.81 meters per second squared, which is G. It's a constant. It will never, ever, ever change. Okay, so put this in the calculator, and that will give you your time. Okay. On B, you're going to use the time that you calculate here, and then you're going to use it in this one. So on this one, you have time, which is that right there. Ignoring air resistance, what will the velocity of the piece of glass be when it strikes the ground? So you're looking for V of F. You always know G, and you just calculated time. So go back, formula sheet. We're looking for V of F. We know what G is. We just calculated how long it took. If done correctly, you could have just as easily have done this one, but you would have to manipulate it more with the square root. You just calculated this, you know G, and you're looking for this. So you would use the VF equals G multiplied by the change of time. Plug in your time, plug in G, which is always 9.81 meters per second squared. You're going to hear me saying it a jillion more times, but it's true. Okay, let me see if there's any other more difficult ones. No, other than using this equation, which is the exact same equation as this, but instead of solving for the vertical difference, so how far it fell, the distance, you're looking for time. So we just rearranged it, and you get this. Add this to your arsenal. Same equation, this one's rearranged to search for time. And I think the rest of them either follow directly along one of these or uses this equation. So hopefully this helps. Get this done. If you have any questions, send me a text over Schoology, a message, or send me an email. I will find a time that I can log on, and I can step you through the equations. Okay, that's it.